about motion. What does motion mean again? Motion means that the body which is moving with respect to time, that body is at motion. That we call that body is at motion, right? So there are different types of motion. Like there are different types of motion, and for the very beginning, we will be talking about linear motion. So linear motion means, so let's see the definition what it says. Linear motion, also called uniform motion or rectilinear motion, motion in one spatial dimension. I'll say it in a very easy words. That means that suppose you are moving, you are walking, suppose, within a linear path or in a straight line. If I am walking like this in a very straight path, that motion will be called linear motion, because I am not changing my direction. I am moving straight forward in one direction. So that kind of motion is called linear motion. Now, if I move like this, suppose I'm going going from this point to this point, and from this point to this point, from this point to this point, this. Can you say that this is a linear motion? This is not a straight line. See, this is a zigzag line from this, right? So this is a zigzag, or this is not not a straight line, right? So this sort of motion, when you are moving in this direction or in this manner, we cannot say that you are at linear motion. Or if a car moves in this direction, we can also say that the car is not moving at linear motion. Now, you can think about a lot of linear motion that you have experienced in your life, right? So just think few of those. You will understand what is linear motion. Like a bus which is moving in a lane or in a road, the road which is straight, the road which is linearly, it's something, it goes in a linear way. So that kind of motion of the bus is called linear motion. Okay, so this is basically what linear motion is. Now we will see that what is scalar and what is vectors. It said that in order to measure, we use certain quantities. So measurement of what? Measurement of anything. We can measure the solid, we can measure the liquid, we can measure the gaseous substances, but we measure in different scales. You cannot measure the liquid you cannot measure the gaseous thing in a solid form, in a solid measurement. Suppose the measurement of this book we generally do in kgs, right? Similarly, the measurement of suppose heat has a certain measurement, like temperature, not heat. Temperature has a certain measurement, like we call 20 degrees Celsius. Someday the temperature of the day is 25 degrees Celsius. So is the degree Celsius measurement and the measurement of this book can ever be same? No, because they are measured in different scales, right? These are scales. So this measurement or of anything, doesn't matter it's a solid or it's something else, this measurement is done with some quantities, right? So those quantities can be divided into two parts. One is scalar and one is vector. Now, what scalar says basically? Scalars are the quantities that fully described by magnitude alone. Example, mass, inertia, speed. So let's try to understand what these things means actually. Mass. What is mass? Suppose if I say the mass of this book is suppose 200 gram. We know that mass are measured in terms of gram, in terms of kg. These are the measurement of mass, right? So it only has a certain measure, and it has certain magnitude, right? It has certain magnitude that this is only 200 gram. Its mass is 200 gram. That's it, right? It has no set other things. It only but magnitude, that is 200 gram. That is its magnitude. So then inertia can also be measured like this. And then you can say temperature. The temperature is also be measured like this. It has only a magnitude that today is suppose 12 degrees Celsius temperature. So that means this temperature has a certain magnitude which is 25 degree. So that sort of measurements are called scalar. So that sort of quantities basically are called scalar quantities. Now, even if you do not understand scalar clearly, now we will understand when we will see what is vector quantities. Now, vectors are the quantities that are fully described by both magnitude and direction. Example, velocity, acceleration. Okay, still now we haven't came across this velocity and acceleration, but let me give you a small idea about this. Velocity is also a kind of quantity measurement, right? So when suppose a car is moving, it has certain velocity. I mean, again, you often heard that car is moving with suppose 40 kilometer per second, right? So 40 kilometer per what should I say, not 40, yeah, 40 kilometer per hour. A car is moving 40 kilometer per hour, right? So what does it mean? It means this is the velocity of a car. A car is moving at this velocity. Again, this is not, there is a certain difference between speed and velocity. This, we often use the term speed in our daily lives, that the speed of a car is 40 kilometer per hour. Okay, so this car, when it's moving with a certain, we rather don't use the term speed, we'll be using the term velocity, right? Why? Because I'll talk about that later part of the slide, why we do not call the velocity and speed same. So rather using the term speed, we'll be using the term velocity, and also we will see why speed and velocities are different. So for now, let's just stick to this, that suppose the velocity of a car is 40 km per hour. So that means that it has a certain measurement, right? And that measurement is done with a certain quantity, which is 40 km per hour. So that means it has a magnitude, obviously, because it is a quantity, obviously there is a magnitude. Now, what is the difference between the scalar and the vector? In vector, it says that it does not only have a magnitude but also a direction. That means when the car is moving towards a certain direction, left, right, front, back, whatever the direction could be, but it moves to a certain direction, right? So when we are measuring the quantity of something that has magnitude and also direction, those quantities are called vector quantities. Now, why we cannot call this book is a vector quantity? Because it has no direction, it has only a mass, which is 200 grams, suppose. It has no certain direction. It is at a static condition. I mean, it is at rest. Rather than use the term, it is at rest. It has no certain direction to move, right? So this is why we call this is a scalar quantity. The quantity of mass is a scalar quantity, and the quantity of speed, the quantity of velocity is a vector quantity. We will know more about the scalar and the vector. So if you are not 100% clear, don't worry. We will be talking about these things more in our next slides.